Okay, well, welcome to today's session. What we're going to talk about today is the resources that we have available for using in the classroom, learning JUMP, actually learning statistical concepts, statistical techniques that you can use so that you can basically get the most out of the software, but also resources that you can provide to your students for their learning to support you in what you're doing. So you have this collection of resources to answer questions about JUMP, and all of that pressure isn't on you. And also just resources and materials to try to enhance the classroom experience. And in this case, we're all moving to an online world, so these resources become even more valuable because you don't have that opportunity to be face to face, and leveraging some of the stuff we have, I think, is really gonna help you. So right now I'm just on the jump.com website. I'm here at the home page, and I'm going to show you a handful of things that are on our website, resources we have there, and then I'm also going to open up the JUMP software and show you some tools we have there to help with your teaching. So I'm going to start with something just a little simple here, and I've done this in some classes that I've taught, and I'm going to click on this tab, Jump in Action, and we have this little section called Customer Stories. So I'm going to click on that. And what we've done is we've put up a collection of success stories of our customers using JUMP. Now, these are sort of high-level descriptions of the problem that the company worked on, how they used JUMP, how they solved it, what was the business case, what sort of decisions they had to make. And it's not meant to teach how to use JUMP. And just to show you, I'm gonna kind of click on one here, and you can sort this by like an application area, by industry. So I'm gonna just pick. Let's just grab one here. Let's just say, oh, this example of what McDonald's was using for predictive analytics. So I'm going to click on that. And you can download this as a PDF, so it's something you can direct your students to, or you can just direct them to this page. So what you're going to read here is this case study of a problem McDonald's was trying to solve, how they used predictive analytics to solve it. It shows a variety of output. Now, again, it's not getting into the details of teaching these techniques, but just trying to give a high-level description of what this company was doing and how they were using statistical techniques and JUMP tools. But where I think these are good, and I've done this in classes that I've taught, is just for a great discussion in class. Hey, let's look at this problem and talk about it. Maybe there's some issues. What other things would you do to follow up? Are there other examples in other industries that something like this can be done in? And I've just found this is just a nice class discussion. Or I've actually known a professor who's given it out as an assignment where he asked kind of follow-up questions and they had to address it. So not data analysis per se, but more discussion strategy, how you use statistics and data science to solve problems. And there's a large collection here. I'm just going to slowly scroll so you can just get an idea of how many there are. And what's also nice of things like this is students get to see where statistics is being used. They get to see the kinds of companies, the kind of industries are using it. And I think it motivates students to see that, hey, what I'm learning is important. This is expected of me when I go out and work. These are good skills to have. I remember when I was studying in graduate school many years ago, and we had a speaker come in that was a quantitative ecologist and talking about how they use statistics to estimate population size and all that. And I remember just being really motivated and excited about that problem. So these, I think, are nice because certain things are going to resonate to students. They're going to see one of these. As I said, I'm just kind of scrolling through so you get an idea. But you can go to the website and see these examples. Okay. Everything from health studies. I'm going to click on industry so you can kind of see. So you can kind of see the application areas here, right? Sports and entertainment. Maybe that's what's going to be the motivation for a student. Okay, now I'm going to move over to this tab called Learn JUMP. And a great way, if you are new to JUMP or your students are new to JUMP, is you can send them to this new user welcome kit. And oh, I have to log in. I apologize about that. But what you're going to get here, and you can look over here on the, I'm going to zoom that in, is basically there's going to be a set of tutorials, everything from how do you import data into JUMP, prepare data for analysis, do some basic analyses, graphs, even getting into predictive modeling. And the point of this, they're all short little videos, maybe 5-10 minutes long, but it's a great way to say, okay, you're new to JUMP, go through this. And so if you're about to start a semester and you're going to be using, let me go back to the Learn JUMP. If you're about to start first week of the class, you can point students to this new user welcome kit and say, hey, everybody, I want you to get up to speed in using JUMP. I need you to get familiar with the navigation, where the tools are. You don't want to spend time in class doing that. So send them to that and say, hey, first week of class, please go through the new user welcome kit so you're up to speed in the software we're going to use for the class. Now, if you're brand new to using JUMP, then by all means, you can go there as well. But inside of here, and I'm going to click on this Mastering JUMP tab. Give a second there. And I'm going to just put a list of videos. Now, I'm going to, in a moment, go to the academic part of our website where we have resources, materials specifically designed for academics, but there's things on other parts of our website that you might find useful as well. And so I'm just going to scroll down slowly so you can kind of see the length of this list. But each one of these is about a 1-hour-long webinar on a variety of topics. Okay. Now, some of them are going to be basic, like, hey, importing data into JUMP or creating some nice graphs and visualization. And some of them are going to be a lot more sophisticated, getting into maybe JUMP scripting language or very specific topics. Like, I'm floating over one that says, structural equation modeling. So, you might be teaching a course in consumer research or marketing analytics, and maybe that webinar will be useful. So these are nice for you, so you can learn the capabilities of JUMP and all these tools. So you can obviously get the most out of it when you're teaching, but they may also be nice things to point students to. And again, we have this sort of organized by application areas or by level. Another section we have in this Learn JUMP part of the website is books. I'm going to click on books. And here we have a collection. Basically, there's two types of books you'll see here. Some of those are put out by SAS Press. And so all these ones that are yellow, these are ones that we put out here at SAS Press. And these are sort of this hybrid of a user manual and textbook at the same time, right? Everything it's taught, it's going to be showing you how to do those analyses in JUMP. And it's going to teach some concepts too, but it's really about making sure that you and the students know how to get the most out of the software and can step through analyses. So these might be good for you to pick up. So we make sure that you're up to speed on what JUMP can do. These are textbook feature JUMP. So if you were looking for a new textbook to use in a class, then take a look here, because these are ones that are going to feature using JUMP. Right now I'm floating over this one called Data Mining for Business Analytics. I've used this book in a data mining and predictive analytics course I taught for MBA students at the University of San Francisco. This is a really great book. So it's a textbook, but the analyses and output and some instructions are shown using JUMP. Now I'm going to go over to the academic section of our website. So I'm under JUMP in Action, and I'm going to this section called Academics. So this is a part of our website that's focused on the kinds of things that teachers and students are going to need when they're using JUMP in the classroom. So we have this organized by faculty, academic researchers, and students. And there's similar content across these three sections, but we're just trying to tailor it. So if you're a researcher, for example, and you go to that section, you're going to see things really focused on what a researcher is going to look for. But I'll start off with faculty. That's what most of you are. And I'm going to click on this middle section called Teaching Resources. Okay. So we have this organized a couple different ways to hopefully make it easy. One way that we have it organized is by the type of course. So for example, if you're teaching a business analytics course, You can click on this. It's also, some of it is by things that are a little bit more specific, like if you're doing a regression, of course, on regression analysis, you can click on that. But I'm going to click on the business statistics section. And what we've done is we've organized a bunch of our content on this section of the site, but that would be relevant for a business analytics class. Now, I'm going to show you where these things are, so I'm going to click on these elsewhere, but I just want to show you how we organize this by course type. So this first section up here, these little short videos and one-page guides that are all about the instructions of how to run the analysis. And again, I'll go to those in a minute here. We have a collection of case studies that would be relevant to a business analytics course. We have some add-ins that we've built, and again, I'm going to show you some of those. We direct you to webinars that are related to business analytics classes. We also have lab activities. So between case studies and lab activities, these are some great assignments that you can give out for like a capstone project or a take-home final exam project, or maybe even a team project. And here's some books. And again, I was showing you that section where the books are. So we're really just trying to tailor this to, if you're teaching a business analytics class, you can direct yourself to this. Here we have some e-learning courses, direction to some of our documentation, white papers, et cetera, that are related to this course type. But I'm going to show you the specifics of these elsewhere. I just wanted to show you how one way we have it organized is by the course type. So I'm going to click on this first tab called Quick Guides. So what these are a collection of sort of instructional how-to guides. And I'm going to just click on one of them here. So let's say you're teaching correlation and regression. So I'm going to click on that. And I'm just going to scroll down so you can kind of see the topics that are here. So we got correlation, non-parametric correlation, some linear regression, logistic regression. And for each one of these, you'll see a video and a one-page guide. And we have some other things too. So some of these will even have little tutorials, which might be great for, I'm going to click on this tutorial here. And so here's sort of, again, another type of instructional resource of how you step through that analysis. What was that up there? I'm going to click on this one-page guide. Now, these are not meant to teach a lot about correlation. There'll be a little bit of a description of what correlation is, but most of this is for you to hand this out to students so you can say, this is how you perform a correlation analysis in JUMP. Here are the instructions, and steps through a sample data set, which you can get access to if you want to use it as a class, or maybe expand beyond what the one-page guide is showing you. And there's also a little video, and these are short, little, 1 minute, 2 minute long videos of how to run the analysis. So again, good resources. I'm just going to click on this correlation coefficient explained, and we have this learning resource called the Statistical Knowledge Portal. So aside from some nice content, you might be able to grab some stuff out of here to use as lecture notes and lecture slides for your class. Again, we're trying to take the pressure off of you having to produce all this material. We want to provide this for you. You're using JUMP. We want to help and make that easy. And some of these things are going to be particularly valuable now that you've all had to switch to this online remote format, right? You don't have that chance to be writing on the chalkboard and talking as much as maybe you do when you're in person. So you have to rely on materials like this. I'm going to back out of these quick guides. I'm going to click on the case studies. I mentioned those. And so here, I'm just going to scroll down so you can kind of see the collection. So here we have a collection of case studies. We give you a quick overview of the field, maybe what the subject is about, what are some of the statistical methods, and try to rank the complexity of it so you know if you're picking a basic one or you're picking a more advanced one. So let's say, for example, I'm doing something, teaching a business analytics class, and I'm focusing on some maybe a marketing application, and teaching predictive models, doing customer retention. This one happens to be about neural networks. So if you click on it, it's going to send you to a little bit more of a thorough description, right? So now it's going to describe the problem a little bit more. It's going to talk about the particular tools that are being used, or the techniques, or the jump tools. And then you can just click on to download the case study and download the data set. So I'm going to just click to download the case study. And let me zoom this in a little bit so maybe you can see it a little bit better. And so what this is going to be is it's going to set up a story. Okay, so here's a particular story. This is dealing with customer retention and attrition for a mobile phone telecommunications company. It's going to describe some objectives, some tasks. There's a data set. And then what we do is we sort of step through analysis. So we might be stepping through part of the analysis, and it's going through here. This way you can make sure the students have all that they need to do the exercises at the end, and you don't have to worry that if you've covered everything, because we do here, as well as how to run it in Jump. Okay, so this one happens to be teaching neural nets, and I'm just going to scroll through till I get to the end here. And at the end, there'll be an exercise that you can provide as an assignment, team project, or a capstone, or take-home homework assignment. Sometimes it expands to another data set. So the case study taught how to do neural networks on one data set, and it might provide another data set for them to do a similar analysis on. I've seen faculty not provide any of this stuff in the middle. They've just provided the problem statement, the data set, what the objectives were, and then just the exercises. So if you take a look at this and you realize, hey, I've covered all these topics in class or the textbook we're using, then maybe you don't have to provide them with this sample analysis that leads up to it. But we want to put that there so you have that as a resource as well. And even if you don't hand it out as an assignment, these are certainly good case studies to talk about in class. Maybe you just want to demonstrate it, or you have a nice data set to use in a storyline. Okay, you can step through that. Okay, so I'm going to back up here. Okay, we also have some online courses. So we've just launched this new course called Statistical Thinking for Industrial Problem Solving. Now this focuses more on the applications of things like manufacturing, engineering applications. However, it's very relevant to many topics in statistics. So even if you're teaching a business analytics class, you would find some of these lectures in here very valuable, because we talk about predictive analytics, graphical analysis of data. Just the example might be about manufacturing, which is certainly relevant to a business analytics class as well. In fact, to go through this whole course, there's probably about 30, 40 hours of lecture materials and instructional materials. So if you click on it, actually I'm going to just do this just so you can kind of see the topics here. So exploratory data analysis, quality methods, decision making, data correlation. So inside each one of these is hours of, so I'm just scrolling so you can kind of see what the table of contents are. So take a look at some of these. You may find that, hey, these are some great little lectures on a particular topic. You can just direct a student to a specific lecture. You don't have to think about enrolling them and having them do the entire course. But you might see a nice sample lecture on a topic that's really nice to use, or maybe they illustrate it with a data set that you think would be a great example to discuss in class. Okay. Here are we got some more video lectures on different topics. We have this section called significantly statistical methods. So again, these are all some lectures on different topics that, again, you can check out, you can direct students to, and hopefully helping you support you in what I know is all of you in a, kind of a challenging position right now, and have to transfer all of your teaching into this hybrid or all online model. So take advantage of stuff we have. We've put together lecture notes, slides, and all of that that you can draw from to help you in this transition. I'm just going to back up some more. We have a place for you to request materials. Okay, so now what I'm going to do is I'm going to open up the software. And I want to show you some resources that we have built into the software. Okay, so I just happen to have a sample data set up here just so I can run some analyses to show you things. Okay, so one thing is if you go under our help menu, of course we have Jump Help, which provides, again, a place for you to learn, but also to direct your students to, so you don't have to answer all of their questions. But we also have a collection of data sets. So I'm just going to open this up here. And there's hundreds of data sets in here that we have organized by statistical topic. We also have it organized by class type. So here's some business analytics, consumer research. I'm just opening them up. So we list the data set, what kind of tools you use. So again, perfect example of stuff that you can use to demonstrate in class or maybe homework assignments. But what I'm going to do is I'm going to show you some things built into Jump that may help you with instruction. So what I'm going to do is I am just going to I'm going to basically do a one sample t-test on this one variable here. So I just ran, for those of you who use Jump, you know that I just ran the distribution platform here, which creates some graphical and numerical summaries of a single variable. And I'm going to do a t-test on this data set. So I'm going to go test mean. And I'm just going to leave it as the value of the mean under the null hypothesis is 0. So I hit OK. And so added to this output is the results of a one sample t-test. Okay. But why am I directing you here? Well, I want to show you some things that we have built in across Jump. So let's say you're trying to get students to understand the concept of the p-value. Well, connected to this output is this little animation we have to teach that concept. So I'm going to launch p-value animation, okay? And this tool pops up where what I'm allowed to do is I'm allowed, as you see here, I'm kind of dragging around the distribution under the null hypothesis. I could also choose to type it in here and pick two-sided, one-sided. But basically what I'm showing is, you can see over here, the test statistic this is changing, the p-value is changing. So this is something you can use to demonstrate in class or give to your students to play around with this. See if you can understand what a p-value is by moving around these scenarios, right? Again, you can change sample size, the standard deviation, the value I'm testing. We also have one built in if you want to teach power. So here it is. I'm launching this tool for teaching power. I can type values in, or I can start dragging around these distributions. And so here I am teaching this idea of, of a type 2 error and power, okay, watching those shaded regions change. Well, I've got the type 1 error specified up there, and you can see all the values that I can change. So I can either manually drag some of these things around or change them. So I'm just going to go over and say, well, what if the sample size was 50? And you watch those distributions change. So something I could do with students when I would teach is sort of say, what if I change this? Can you guess what's going to happen? Well, you're not going to be able to guess it exactly, but you can say things like, if I change this, is the distribution going to get wider or narrower? And you can kind of watch that stuff happen. So there's a few places that we have this stuff built in. I'm going to show you another one. So I'm going to run what's called a capability analysis. And for those of you who are not familiar with capability analysis, basically this is where you evaluate how well a process is performing to specification. Let's say in a manufacturing process or any kind of process for that matter, you're collecting data on it, and you want to see, well, how well does it do to specs we might have on the process. And so I'm just typing some lower specs and upper spec limits here. I hit OK, and these are a bunch of metrics that get computed. But basically, what a capability analysis is after is what percentage of your process is outside of your specifications. So it fits a distribution to the data. In this case, it's fitting a normal distribution, but I can pick others. It shows the specification limits as those red lines, and it's basically trying to get an estimate of how much of that distribution is outside of spec. But built into here is we have this interactive tool on how to teach capability. And again, you don't have to be thinking of it as this technique called capability analysis, you're just sort of trying to teach this idea of, well, what is a distribution? What does it mean when we model a variable with a distribution and now compare it to things we might care about in a process? And so what I can do is I can start moving around the specification limits. Okay, here I am sliding the upper and lower spectrum limit around. I can move the mean of the distribution. I can move the standard deviation, and I'm watching the percentage of that distribution change relative to these spec limits and targets that I have set. So this is like if you're teaching the concept of the z-score. It's kind of like what we're doing here. We're moving around distribution, characteristics of the distribution, moving around values that we want to see the proportion that's larger or smaller than those values we've defined. So there's places in JMP where you'll see these little animation tools pop up, which I think are really great to teach a concept. Another thing that we have built are these sample size explorers. So this is where we're going to study the relationship between sample size and things like power. We can also do it for the margin of error in a confidence interval. So I'm going to just pick that one. So let's say we're teaching a one sample t-test. You can pull up this Explorer tool. And so basically what you're doing is you're trying to solve the problem of how much data is required to produce a confidence interval that has a certain margin of error. And so you can kind of type these values in here. You can see I can type in values. I can move around the sample size, move around the margin of error, play with alpha, play with the variation. And actually I can do this as a confidence interval, a prediction interval, or tolerance interval. And I can watch how the answer changes based upon dragging this stuff around or changing characteristics. So again, these are things where what I would do with students is I would say something like, what if the standard deviation, what if I assume the standard deviation is half the size? Instead of it being 2, it's 1. And you try to get students to guess, like, well, what's going to happen? And so if I put a standard deviation of 1 and type it in, I'm going to see how that margin of error changed. And so if I wanted to achieve the same margin of error, let me go back to 2 here. So you see the margin of error is 1.3. So if I change the standard deviation to 1, well, to get to a margin of error of 1.3 like I had before, you can start watching what's going to happen to the solution. So you can kind of drag these things around. Now I'm going to pull up that other one there for power, same kind of thing. Pull up for one sample t-test, and you see how I can drag that around and sample size and power and watch how results change, or things like change the standard deviation. Okay, and you're seeing how my power is being affected by when I do that, picking different sample sizes. So yes, this is a tool that you use to figure out sample size. It's a great way to teach because it's interactive and dynamically changing. Okay. So I think it's great for students to play with this to help them sort of understand the concept of what's going on, and also a great demonstration in class, where you can ask a student, what's going to happen if I collect twice as much data? How is the power going to change? What happens if the standard deviation is twice as big? How are these answers going to change? And you can see we have that for a bunch of different scenarios. The one sample inference for mean, proportion, variance, as well as 2 samples. And again, margin of error if you want to approach the problem that way. So you can show students how the width of a confidence interval changes as you change some of those characteristics. We also have it for reliability. So if you're teaching like an engineering class, that's sort of where you determine, how much data do I need to collect to demonstrate that a product or a process has a certain level of reliability. Okay, the other thing here I'm going to pull up is these interactive tools we have. So I'm going to go to this sample data library. And what I'm going to do is kind of point you to this area right down here where we have things like simulation tools. So if you're teaching things like the central limit theorem, I'm going to click on that. So you basically are pulling in different data sets of different size, and you'll see what happens. But I want to direct you to a different place for these. We have calculators. So if you're teaching, for example, something like a conference interval, I can either bring in raw data I have, or I'm going to type in manual data. So you can sit here and use this as a calculator to play around with things. So you can say, okay, I got a sample. I took a sample of size, say 50. I got a sample mean of 10. A sample standard deviation of 2. Okay. And now I can see this is a confidence interval. Right? I get basically the t multiplier. I can see what the standard error is, and I got a little diagram and a picture of that confidence interval. I can start changing things, So I can say, well, what if instead of collecting a sample of size 50, what if we collected a sample of size 100, had the same sample mean, sample standard deviation? Now we can watch how that width changes, and you just saw how that width got more narrow, and we can see those values. So this is a way to sort of, you're not analyzing data per se, we're sort of just using it as a calculator. But it's a nice way to change something and watch what does or doesn't change in the answer. So classic things we try to get students to understand. And I always like to do this by changing one thing and seeing if they could guess what changes or doesn't change, right? So what happens if we change the confidence level? So what if we're changing, say, confidence to 80%? The students are going to be able to guess, like, okay, sure, the interval gets more precise. However, we're less confident that the answer is even correct in the first place. So great place to change little values and watch what doesn't change in the solution. Okay. We also have these interactive teaching tools. Okay, so you can see here we could teach different concepts, different things like what's the difference between the normal distribution and the t-distribution. Let's demo how something like what is collinearity or what is correlation. I'm just going to click on one so you can see, right? So we can teach this idea of correlation. But what I want to do is I want to pull up this tool on regression. I like this one a lot. Drag this over here. I'm just making these things bigger. You can do this in a lot of places in JUMP. You can make stuff bigger. So here's a data set. Now I can bring in my own data sets. I can define a data set, and so I'm picking a correlation. So say I drag this correlation around. I can change the slope, change the intercept, and pick a particular sample size. Here I pick 25, but I can pick more. Sliding that around so you can see. I can also create my own. So I can define, like, say, a min and a max of what I want to see. I can also add data points. So you see how I'm adding some data points here. Now what you can have students do is you can say, okay, let's see if we can understand, well, what is least squares regression? And so you can ask the students, okay, I'm going to make this a little bit bigger here so you can see. Okay, why don't you draw a line that you think goes through the data? And so they can drag this around and see if they can produce a line that they think fits the data. And then you can say, okay, well, let's see where the least squares regression line is. Oh, pretty close. I'm proud of myself there. I eyeballed it pretty well. And so now it draws the least squares regression line, shows you all the standard regression output. Okay, so down here is a sample of the residuals. I'll just make that bigger so you can see. And fit in this graph is that least squares line. Now each time I draw a sample, it's going to get a different data set. Actually, let me remove the line that I fit to that one data set. So every time I hit draw sample, it's going to draw a sample of size 30 from a distribution that has a known relationship between a response and a predictor, right, with a given correlation, given intercept and slope, given mean, standard deviation, all of that. And every time it draws one, it shows the fitted line, gives me all the regression output, and draws that line here. And I can keep on drawing a sample. And as I keep doing this, well, what concept are we illustrating to the students? That idea that a confidence interval for that fitted line is going to be most narrow in the middle and widest at the edges. Now, I know there's a formula to show that, but what a great way to illustrate it by simulating the idea of drawing a sample of a given size. Now, I can also use this, if I add a data point here, I can use this to teach students this idea of leverage. So here I am pulling a data point way out on the extreme, watching, hey, look how much influence it has on this regression equation. If I bring it into the middle and move it up and down that same distance, I can show the students, look, I'm moving that same distance in the y direction, but it's really not changing the equation that much at all, not changing the residuals that much at all. You can see how the point is floating in the lower right graph in the residual point. So I'm kind of showing what that residual is and showing that influence. Okay? Now, I can also pick other statistics to show. So I happen to be showing the fitted line, but if I was teaching, for example, a sampling distribution, I can say, well, show me the sampling distribution of the slope. Now, I've already drawn a whole bunch of samples. That's why the distribution is already drawn there. But every time I keep on drawing another one, I'm adding to that sampling distribution. Right? So I can start teaching that concept of like, oh, you know, look at the shape of that sampling distribution, sort of starting to take on that symmetric shape, right? That idea of what that's converging to. And you can see here's a distribution of r squared, and I'm drawing those, and we should see that r squared where that should center around, right? It should center around the square of that correlation. You can even show the correlation as well. I can drag these around if I want to make this a little bit easier to see. So each time I draw a sample, I'm watching that correlation, and these correlations should sort of get close to about, in this case, it's 0.79, but we should kind of see that as we're doing that, trying to teach that concept of what a sampling distribution is. I'm going to close this one. We have other tools, so I'm going to click on, let's say, if we're teaching the concept of a sampling distribution for the sample proportion. Okay. So same thing, I define the parameter, in this case 20%, I pick a sample size, and then I keep on drawing. So up at the top here is, right, it's binary. In this case, this is set up as, let's say the characteristic of interest is blue, but I can define, if I want to keep it general, you know, I can just call it A and B, right? And so here I am drawing. Each time I'm going to get a distribution of percentages of A's and percentages of not A's. And down the bottom, I'm watching the sampling distribution of the sample proportion. So I'm able to illustrate to the students why we may use a formula that's based on the normal distribution. Why? Because the distribution of the sample proportion in the long run starts to take on that symmetric normal shape. And we can see that, right? So if we're teaching that idea of why we're using that symmetric formula based on the normal distribution to, say, build the confidence interval, test the hypothesis, that's the reason why. We're sort of seeing that. Here, I'll pull up the confidence interval for the population mean. So very similar, I find a particular distribution, a sample size, a confidence level, and every time I draw a sample, it's going to draw a sample of size 25 from a distribution with a known mean and a known standard deviation. And down the bottom right here is it's drawn a confidence interval. Okay, so I can see the mean and the standard deviation of that particular sample, and I can keep on drawing. And every time I do that, it creates a confidence interval. And every time it misses, okay, so you see we just got 4 there that missed. Every time it misses the known mean of the defined mean of 100, it's going to make that confidence interval red, and when it correctly captures it, it's green. Now I can do this instead of just doing it one at a time. If I want, I can do it 20 at a time. So every time I hit draw samples, it's going to draw 20 at a time. And what am I illustrating here? Well, I'm teaching the students that concept that in the long run, you will see that the percentage of intervals that capture that value 100 should be around 95. Why? Because I picked a confidence level of 95. So if I wanted instead to show the students, well, what if I change that confidence level to 80? Okay. Same sample size of 20, same known mean and standard deviation for the population. And every time I do this, instead, I'm going to watch this value should converge around 80 because I changed it to 80. Right? And if I did something, showed the students, okay, well, what if I took a lot more data? What if each sample size here, well, I'm going to move this up to 100. I'll go back to doing this just 20 at a time. Well, what if I took a larger sample size? You know, and you're trying to show the students, well, that doesn't matter if my confidence level is set at 80. I'm still going to watch, in the long run, this percentage of times that the interval correctly captures the mean is still going to be around 80 because that's my confidence interval, regardless that I picked a larger sample size. Now, granted, those intervals are going to get narrower because they're more precise with larger data, but it's still going to correctly capture it, that defined percentage of time. So again, another tool where you can change characteristics like the sample size, the mean, the standard deviation, confidence level, and watch what's happening in this simulation. I know, I find things like this really great teaching tools. So students can get out of the formula, out of the math, and develop a more conceptual understanding. So you can see the list of things we have here. Everything from teaching sampling distributions, teaching a hypothesis test, teaching confidence intervals, the central limit theorem. So I'm going to go to this section for students. So this jump basics section, this is directing them to those quick videos and one-page guides that I was saying. So this is another great place if it's the start of the semester. So here we go, like a high-level use of jump, not getting into heavy statistical techniques at all, but just porting data. How do you create some graphs? How do you produce some basic output? Save your output. This is another great place to, at the start of a semester, direct students to in that first week of the class. Say, hey, go through these videos, take a look at these one-page guides. So you don't have to do this directly. That's these quick little videos and instructional materials. Now we have this webinar library. Okay, so I'm going to go to our academic webinar. Okay, so here we have a collection of webinars. Each one of these is about an hour long, and they're going to get into how to use JUMP on these specific topics with a lot of the functionality, as well as doing some teaching. But again, they're more designed to get you and your students prepared on how to do these analyses in JUMP and the kinds of tools we have. So you can take a particular topic. So if you're teaching, for example, maybe some ANOVA and regression, then you can click on this and we'll have this 1-hour video about using JUMP to do ANOVA and regression analyses. Thanks for reminding me to point that out, Pani.
Yeah, and then also this session is going to be recorded, and we'll email out the link of this recording within the next week.
Now, another great resource that you might find is our user community. So I'm gonna click on our user community, and if you haven't gone to this yet, think of this as something beyond the built-in help that we have. So you may have a specific question on something that you're trying to do and you're not able to find the answer in help. Well, you can type that question in here, and either you'll find an answer to that question through these people in our community that have maybe asked that question before. So I'm going to just type something in. I'm going to type in, changing color of data points on a graph. Okay. And you can see some sample things are popping up. So I'm going to search And now you'll see some discussions that are talking about, changing the color on graphs, and you can possibly find what you're looking for. If you don't find what you're looking for, you can submit that question, and then someone will respond to you. And that will be either a person inside of JUMP responding to you, or one of our power users out there who just like to answer questions and contribute to the community. And you can contribute to the community as well. You can also use this to look for data sets that you might want. So I'm going to go to this little section called File Exchange. And this is where people will exchange maybe some scripts, some add-ins that they've built. Okay, so I'm just floating over here so you can see what it is. And so right over here, somebody just built an add-in to do a spider plot. Okay, so that plot isn't in JUMP yet, but somebody built an add-in. So I'm just going to click on it to show you what this is. And I'm going to scroll down a little bit. So one of our employees here, Mike Anderson, built an add-in to do a spider plot. So this is used a lot in consumer research studies, taste test studies, if sensory perception studies, if you've ever done that. And so somebody created this add-in for it. So you can download the add-in. It just basically gets added to JUMP. You'll see an add-in menu get added at the top of your menu bar, and then you can start using that tool that somebody built. So this is a great place to see what how people are expanding JUMP beyond our built-in platforms. You can also use it to find some data sets. And so here's some sample data that people have added. And so you can type something in and you can say, hey, I'm looking for a good data set on, teaching regression analysis with an outlier, and, see if you can search and find it. I encourage you to share data sets that you might have. So you might go in here and say, hey, I've got a really great data set that I've produced. You want to make that available to other faculty and students to have access to. By all means, put it up there. So it's a great place to search for questions, submit a question, basically just become more of a power user of JUMP, because you're gonna find all sorts of scripts and things that people have built. Perfect. And what we do is we'd be happy to do a session just for your class and maybe some of your colleagues. So if you are thinking, hey, we're about to start the fall semester soon, let me have Kevin come and do a little virtual presentation to the class to kick everybody off and get them started. Or maybe you want other colleagues to see JUMP and how you're using JUMP. That's what we do. We're here to support you. So reach out to myself or Pani, and we'd be happy to schedule a virtual session to do with you. We can tailor it on very specific tools, maybe some specific data sets that you have. It doesn't have to be a generic demonstration. We can really target it to the specific topics that you might be covering in class and specific tools in JUMP you want demonstrated.
Great. Thank you, Kevin. And thank you, everyone, for joining us for today's webcast. And enjoy the rest of your day.
All right. Thanks, everybody. Take care.